Okay, we're back with an example with partial fractions. This is the first of two examples. Right behind me I've got some basic steps, but ultimately if you go through the video and you see the process a couple of times, both this video and the next video, I think you'll start to get the gist of it. This is one of those situations where practice makes perfect, and once you're feeling good about it, I don't think this problem will be that much of a hassle for you at all on the exam. So what we're looking at here is the antiderivative of 1 over x squared minus x minus 12 dx. We're looking to find that antiderivative. If we make u equal to the denominator, we could do that. However, there is no du that corresponds in the numerator, so therefore we are out of luck there. So we have to go to plan B, and plan B is partial fractions. Okay, so what are we going to do? Well, for starters, we're going to factor the denominator. So we see a quadratic, and that's usually how it's set up, is a quadratic. Sometimes it could be a cubic, but no matter what, you're going to get some kind of some kind of denominator which can be factored. We're looking for two numbers which multiply to negative 12 and add up to negative 1. Okay, and so obviously 4 and 3, one of them's got to be negative because we're multiplying to negative 12. So negative 4 and positive 3 will produce the sum of negative 1. So this denominator right here is really the same thing as x minus 4 times x plus 3. Okay, so there's our rewrite. Let me just separate that. Okay, so we've taken this quadratic and we just turned it into a product of two binomials. Now now that we have two binomials, we're going to break this apart. Okay, because by definition, if the denominator is x minus 4 times x plus 3, and from the previous video we know that this is really equal to a sum. It's equal to a sum, I still need my antiderivative, where one of the denominators is x minus 4, and the other denominator is x plus 3. Okay, so if we were to add these two fractions, we would get a common denominator, and the common denominator would be this. So really we can break it apart in the reverse manner. Now what we don't know is what happens to the numerator when we break this apart. So we have some kind of numerator up here, and we have another kind of numerator right there. We don't know what they are, so we're going to use just capital A and capital B. That's a standard practice, but ultimately you can pick whatever two letters you want as long as it's not x, because that's already being used. All right, so if you want C and D, go for it. But we've got A, we've got B, we've got a dx at the very end, and what we've done is we've just taken this single fraction and we've broken it up into two partial fractions, okay? And now we're going to work with this because this is something we can do an antiderivative of. Okay, we have the antiderivative x minus 4. Well, that's going to lead us to the natural log, all right? We've got, in essence, a number over x. A number over x is, and then we want to take the antiderivative of that. It's a natural log result. Okay, what we don't know and what we have to determine before we take the antiderivative is what is the value of a which will make this true. All right, we need a value of a and we need a value of b. Once we determine what a and b are, then we can do our antiderivatives. Okay, so now that's what we're looking to do here. We're looking to find a and b, and we're going to do so by choosing some values of x. We're going to choose wisely, just like Indiana Jones in The Last Crusade. Okay, so what's going on? We know that ultimately, in order to add these up, there would need to be a common denominator. So for right now, let's just write. We got a over x minus 4, and then we've got b over x plus 3. And we want to add them. Okay, we can't add them right now because we don't have a common denominator. So let's make a common denominator. That means we have to multiply the first fraction by x plus 3 in the denominator, and we have to multiply the second fraction by x minus 4 in the denominator. Now, if we multiply the first fraction's denominator by x plus 3, we must do the same thing in the numerator. So we have x plus 3 up there. And if we multiply the second fraction's denominator by x minus 4, we must do the same thing up here as well. And we know that now that we have a common denominator, we can actually add these two fractions together. Okay? And if we add them together, then obviously the denominator will stay the same, and we just add the numerators. We're not actually going to do that at the moment. But what we do know is if we add these two together, we have to get this. Because ultimately, remember, this is what our problem started off with. So we have the x plus 3 and the x minus 4 in the denominator, and we need a 1 up in the numerator. Okay? So what does that mean? Well, fraction plus fraction equals fraction. Ultimately, Denominators must all be the same, and they are. And the numerator, the first numerator plus the second numerator, must equal that answer. So what does that mean? A times x plus 3 plus b times x minus 4 must equal 1. All right, let me just separate this with an orange line because I know we're getting cramped here. Okay, if we can determine this value, we can figure something out for a and b here, then we're going to be good to go. Okay, and again, all I'm doing is numerator plus numerator equals numerator. And that's just basic fraction addition. Okay, so what do a and b equal? Well, this has to be true for any value of x. Okay, because no matter what, we have to get 1. Regardless of what x is, the result has to be 1. So ultimately, we can plug in whatever values of x that we want to. So let's choose wisely. Let's choose two values of x, which are going to cause two of the variables to be annihilated separately. Okay, in other words, what if x was equal to negative 3? Okay, if we make x equal to negative 3, watch what happens. Okay, we have a times negative 3 plus 3, a times 0 will be 0. So if x is equal to negative 3, then we have a times 0 plus b times, and again, x is negative 3, so we have negative 3 minus 4. Negative 3 minus 4 is negative 7. Okay, and that must be equal to 1. So a times 0, which means that's out. So b times negative 7 is 1. That means that b must be equal to negative 1/7. Okay. We need to figure out what a is. Well, in order to figure out what a is, we got to annihilate the b term. What value of x would cause b to get wiped out? 4, exactly. If x is 4, then this will become b times 0. So let's make another case here. If x equals 4, all right, if x is equal to 4, then what we have is we have a times 4 plus 3, so a times 7, plus b times 4 minus 4 is 0, and that still must be equal to 1. All right, so 7a plus 0 is 1. Divide both sides by 7. A is equal to 1/7. Okay, so now that we figured out what a and b are, we can actually go back up here and we can sub them in. We can sub in 1/7 for a and negative 1/7 for b. All right, so that gives us, we got here, antiderivative. We have 1, I'm just going to write it up in the numerator for now. I know it gets a little messy, but just bear with me. 1/7 over x minus 4 plus negative 1/7 over x plus 3 dx. Okay, this, believe it or not, is the same as that. And if you don't believe it, then add these two together, and you'll see that the result will be 1 over x minus 4 times x plus 3. That's what the breakdown does. All right, let me steal the eraser. I'm going to get rid of this part right here, because we haven't answered the question yet. All this work that we've done has been great, but the charge was to find the antiderivative, and we still have not found the antiderivative because the symbol is still right there. So let's write this again. That makes things a little bit easier. Okay, we have 1/7 over x minus 4. So antiderivative, and we have 1/7, and that's times 1 over x minus 4. In essence, I just move the 1/7 out front. Okay, and plus, actually, you know what? We're going to go minus because it's negative. So minus 1/7 times 1 over x plus 3. And this is all dx. And we really don't need those 1/7 in there. They are coefficients. So they can get moved out as long as we have two integrals. So here's our integral. We're going to move the 1/7 out front. Okay, and we're left with 1 over x minus 4. And then we have minus 1/7, and we have another integral of 1 over x plus 3. And that goes to our basic understanding of the properties of an integral, which say that if you have a sum or a difference in the integrand, you're allowed to break that integrand up into two integrals. Okay, I left out a dx, so let's get a dx here and a dx there. All right, we want our differentials in there just to be correct. And the idea, though, is that yes, we have these coefficients out here, but ultimately now look at our two integrands. They're both 1 over x's, which means that these can both be anti-derived. Up here, we could not get the antiderivative, but now we can by breaking that one fraction up into two partial fractions. Okay, natural log. 1 over x is a natural log. Now technically this is something ugly, but the derivative of x minus 4 is just 1. So if we were to make u equal to x minus 4, du would be dx, which means we don't really have to do u substitution. We can just go right to our antiderivative. So again, finally what we have here, we have 1/7, and then we have the natural log absolute value x minus 4 minus 1/7 natural log absolute value x plus 3. And we're doing an antiderivative, so what goes at the very end? Yep, don't forget your plus c. So this right here is our solution. Okay, it's complicated. These problems can take some time, but it's going to be on the exam. This will happen probably around question 20, 25. There will be a partial fraction question, and you can get this point. You can absolutely get this point. It'll take a little bit of work, but you can get it. One quick note, notice that we had 2 natural logs in our answer, and natural log is going to be in the answer. When you're doing these partial fractions, the goal is to go from something where you cannot get a natural log as the antiderivative into something which does produce the natural log. And if we were, in fact, to derive this boxed equation right here, you would end up with 1 over x squared minus x minus 12.